Welcome to Math 1400, Nunez Community College. This section today is going to be sort of a precursor to what's coming up in the class. It goes along with section 1.1 and it's called the unit circle. The unit circle is going to be a circle on a coordinate plane, and the unit circle only talks about the angles and their units. So if we have, the first one is going to be in degrees, and if we have a central angle whose initial side and terminal side are on top of each other, then we say that it's 0 degrees, or if we make one complete revolution, it is 360 degrees. We're going to divide up this unit circle into angles that we use in this class. So if a complete circle is 360, half of a circle is half of that, or 180 degrees. Straight up would be half of 180, or 90 degrees. And if we're counting by 90s, this would be 270 degrees. This is the measurement of the axes. Now, one of the special triangles that you've learned about in high school was a 45, 45, 90 degree angle, a triangle. So we're going to divide this into 45 degree angles. The first one being 45 degrees. 45 and 45 is 90. Plus 45 is 135 degrees. 180, 225, 270, and 315. And if I add 45 more, I come back to 360. So these are angles that we're going to refer to within this class. The second of the unit circles, if you will, is going to be the other triangle that's special, which is a 30, 60, 90 triangle. So the four main angles are going to be the same: 0 and 360, 180, 90, and 270. Again, the same as on this one. But now I'm going to split it into 30 degree increments. So that each one of the angles, again, that we refer to is going to be 30 degrees. 30 plus 30 is 60 degrees. 90, 120, 150, add would be 180, 210, 240, add being 270, 300, and 330 degrees, and finally 360. These are the unit circles in degrees. The other measurement that we're going to use in this class is called radians. So I need to explain a radian before we can convert the same unit circle in radians. So the first thing that we have is a radian is going to be the measure of a central angle. Central angle being the center of the circle is its vertex. It's the angle that happens when we have a radius, which is the sides, and we have something called an arc length. This arc length means around the outside of the circle, but only part of it. It's not the whole circumference. This radian, or theta, this radian occurs when the arc length is equal to the radius. So 1 radian occurs when the arc length equals the radius. When the arc length equals the radius. So this would be 1 radian. And if I can section it off, I would have another radian, and 1 more radian, and so on until I got all the way around the circle. However, a half of a circle being 180 would fall a little bit it would be a little bit greater than the 3 radians. It would actually be 0.14 radians more than 3. In other words, half of a circle would be 3.14 radians, and we designate that as pi. That's where your pi comes from. So in the radian measures, the answers are going to be in pi units. So now we're going to look at that same unit circle. Pardon me, I have to erase this. We have to use the same unit circle, but we're going to do each one of these measures in radians. This will help us out when referring to different situations within the Math 1400 class. So on the first one that we did, I'll draw my circle. And we know that this is 0 radians. We know that the half of a circle was pi radians. We just saw that by looking at 3.14. So a whole circle must be 2 pi radians. Pi plus pi, 2 pi. So if we look at this being pi, this was half of the circle, half of the half circle, or a quarter of the circle, which would be half of pi. It would be pi over 2. And counting in 1/2 increments, that's 1/2, that's 2 halves, which is 1. This would be 3 halves, 3 pi over 2. Now, on that first circle that we do for the degrees, we did it in 45-degree increments. Well, we're cutting this into fourths. This is pi. This is 4 sections, so it's each one is 1/4 of the pi. So therefore, this is pi over 4, or 1/4. 2 pi over 4, we simplify it into 1/2. 3 pi over 4, and then 4 pi over 4, which is 1. Continuing in the 1/4 increments, this would be 5 pi over 4. This would be 6 pi over 4, which is 3 pi over 2. 7 pi over 4, and then 8 pi over 4, which is 2 pi. So this would be the unit circle in radians if it's divided in the same angles as the 45-degree angles. For the 30, 60, 90s in radians, it would look just a little bit different. We have our main angles, 0, 2 pi, pi, pi over 2, and 3 pi over 2, okay? But we divided this into thirds, each one into 3 sections, which would give us a total of what? 1, 2, 3, 4, 5, 6 slices, or 6 increments of the pi. So therefore, each one is going to be 1/6 of a pi. So we got what? Pi over 6, which is 1/6. 2 pi over 6, but 2 pi over 6 converts to pi over 3, or simplifies to pi over 3. I have 3 pi over 6, which is pi over 2. I have 4 pi over 6, which is 2 pi over 3. 5 pi over 6, which is 5 pi over 6. 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And 11 pi over 6, which is 11 pi over 6, bringing us back to 12 pi over 6, which is 1 complete circle. These are unit circles. These are going to be the angles that are going to be used throughout Math 1400. Hopefully that you can watch this video and maybe refer back to it if you need to at a later date. Thank you so much.